Hey there. All right, we're going to get some practice with converting metric units today. So we are going to, first off, King Henry this. Anytime I convert metric units, I like to use King Henry drinks unusually delicious chocolate milk. And the idea here is that each of these letters is going to stand for one of the metric prefixes. K is kilo, hecto, deca. U stands for the base unit, which is going to be anytime you see a unit by itself. So that'll be meter, liter, gram. In the case of chemistry, we're doing joules a lot. You may also see that as moles. In chemistry, there's not a lot of mole conversions in that sense in chemistry. Then we have the little d is for deci, that's 1/10, centi, and milli. This one comes up quite a bit in chemistry, and so does the unit. So most of the time in chem, you are going to convert either from the base unit to milli or from milli to the base unit. And really, the idea is that we need to convert metric units because our equations require it. A lot of our measurements in chemistry are going to be small measurements. Mass a lot of the time is in grams, so that'll be a base unit, but volume a lot of the time comes in milliliters. And our equations require a lot of those things to be converted. Specifically, things like when we're talking about gases, like PV equals nRT. Pressure has to be in atmospheres. Sometimes you'll see it in kilopascals, which is this one. If you're measuring in pascals, you'd have to convert to kilo. Volume is that thing I mentioned, the milliliters and liters. That happens a lot. N is moles. Usually we'll get it in moles. R is a constant, and then T is temperature, which is, I'll do a video on that later. But for this equation specifically, you would need to be in Kelvin. Then we have the molarity equation. Molarity equals moles divided by liters. And that's to tell you how much stuff is in your other stuff, concentration. Liters, a lot of the time, is not what you're measuring. You'll get something in milliliters and then have to convert it to liters to fit into this equation. So that's the basis of all of these yucky unit conversions that nobody likes to do. Okay, so anytime we're converting, I like this King Henry method. For this first question here, we are doing 1 meter and converting that into centimeters. So again, if I'm going to look at King Henry here, I am going to erase some of this so we have some room to work. All right, we are looking at meter, which is going to fall on the base unit, that's M, the unit all by itself, and we're trying to get it to centimeters. So in that case, we have to jump 2 places to the right, and we're going to do the same thing with the decimal. In 1 meter, I'm going to ditch that M, and we're just going to leave it as 1. In 1 meter, the decimal is right there. It's not written, but that's where it belongs. So we are going to move that decimal 2 places to the right to mimic the jumps here. So that's 2 places to the right. Now I'm going to have my decimal back here, and I have to fill in those empty jumps with zeros, meaning that 1 meter is equivalent to 100 centimeters. So anytime we are moving our decimal to the right, it is the equivalent of multiplying by 10 for each jump, which is how we got from 1 to 100. 1 times 10 is 10, and then 10 times 10 is 100. That's how we get it. In this next case, we have 700 centimeters. So in that case, we're working with centi and moving over to the base unit. That's the equivalent of dividing by 10 for each jump. So our 700 centimeters with a decimal back here, we move it 1 place there, and that is going to represent dividing by 10. If we move it again, that's dividing by 10 a second time. So if we move the decimal there now, I would have 7.00 meters. And for the sake of significant figures, we will keep those 2 zeros. But 700 divided by 10 would be 70. Divided by 10 again, you get 7. So you could look at it that way. Moving the decimal either direction is either multiplying or dividing by 10, depending on what direction you're going. But knowing this King Henry drinks unusually delicious chocolate milk and then just tossing the decimal around, to me, is a lot easier. It's, of course, going to depend on your preference. Let's keep going. Okay, 25 milliliters is being converted to liters. This is something that'll happen often in chemistry. So we're going to take those 25 milliliters with a decimal right here. Milli is right there, and I want to get to the base unit, so I will have to move 1, 2, 3 times to the left in order to do that. So 1, 2, 3 times to the left would put my decimal right here, and I got to fill that in with a 0. So we will have leading 0.025 liters. Now, I like the leading 0 just because I am not going to miss it when I type in the calculator. Now, if you had something like 0.25, then I would be afraid I would miss it. So I always do the leading 0. It's just my preference. But because this has a 0 at the beginning, you're not going to miss it. But that's I'm just in the habit of doing that. 520 milligrams, getting that into grams. Milligrams, that little m tells us that we're working here with m, and g all by itself tells us we're working with the base unit. So I will need to move 1, 2, 3 places to the left in order to convert this unit. My decimal in 520 is behind the 0. If I move that 3 places, it'll pop all the way over here, and we would have 0.520. Again, this is where I like to put in that leading 0, so when it comes time for the calculator, I know for sure I am not going to miss it. So there you have it. 520 milligrams is 0.52 grams. Now, in terms of significant figures, you maybe don't want this last 0 because this only has 2 sig figs, so you would want your conversion to also have 2 sig figs. So we would maybe ditch that 0 just to maintain that. There will be a practice video with significant figures soon. Okay, now we have 25,860 joules, and this is something that'll come up a lot, especially in that matter and energy unit. We're working with joules, which is the base unit for energy. So I'm going to start with U, and I want to get to K, kilojoules. So I'm going to go 1, 2, 3 spaces to the left. My decimal in this number is behind the 0. If I move 1, 2, 3 places to the left, I'll be right between the 5 and the 8, meaning that I would have 25.86 kilojoules. Both of these answers, or both of these values rather, have 4 significant figures. So I'm going to drop that 0. There we have it. Going from 4.5 liters to milliliters, this you may have gotten 4.5 liters as a result of your math, but you're measuring in milliliters perhaps in a lab setting, or the question asks you specifically how many milliliters. It's quite a few. Okay, so liters, we're working with that base unit again, and we are trying to get to milli, which is going to be 1, 2, 3 spaces to the right. So I'm going to take that 4.5 and move the decimal 1, 2, 3 spaces to the right. I'm going to fill in those empty jumps with 0, pop my decimal at the end, and that will give me the 4,500. Now, back to significant figures. I would not write the decimal here just because that would change my answer to have 4 significant figures. This has 2 sig figs, so I want my conversion to also have 2 sig figs. So I'm going to leave the decimal off of that answer. Okay, finally, we are converting 34.8 grams into milligrams. So grams, of course, is that base unit. It's G all by itself. And we're going to move 1, 2, 3 spaces to the right. 1, 2, 3 spaces to the right. Fill those in with zeros, and we get 34,800. No decimal, so that each of my answers has 3 significant figures. All right, if you have any questions, leave them in the comments section below the video. Subscribe so you don't miss the next practice video, and I'll see you there. Bye.